At this point in the course, we are beginning to explore dynamic fields. Up to now, everything has been static. And that means that the time derivatives of all of our quantities of any charge, current, and fields, all of that is zero. In this case, that's not going to be true anymore. And that is because Faraday's law specifically refers to the time derivative of a field quantity. What Faraday found is that a time-varying magnetic flux can produce a non-zero voltage around a closed loop. Now, this is pretty significant. This goes against Kirchhoff's voltage law. And it also contradicts this idea of the electric scalar potential, right? Previously, we used to say that the voltage is equal to minus integral of E dot dl. And since the electric field is conservative, you could also say that the voltage around a closed loop is equal to zero. Now, this is not true anymore. Meaning that in the presence of a time-varying magnetic flux, the electric field is no longer conservative. Here's a statement of Faraday's law in integral form. Faraday's law in integral form is that V EMF, and I'll tell you in a second what an EMF is, which is this integral, closed loop integral of E dot dl, is equal to minus the time derivative of the magnetic flux through that loop. So if I were to write that out, it would look like minus d dt of a surface integral of b dot ds. And this surface is the surface that this contour is the boundary of. If there are multiple turns in the loop, then the EMF voltage is minus n times the time derivative of that flux. Now that, let me tell you right now what an EMF is. So VEMF represents an electromotive force. Which is specifically an electric potential source, not a potential drop. An EMF does work on charges. And increases their potential energy. This concept, this Faraday's law concept right here, and also the statement above it, is how electric motors and electric generators work. So it's a very important law, and it has a lot of interesting implications. There are 3 different ways to generate an EMF. The first one is a transformer EMF, which means a stationary loop and a time-varying magnetic field. The second way is a motional EMF, which is a moving loop, or one whose area varies with time, and a static magnetic field. And the third way is a combination of the first 2 ways. So a combination of the transformer and motional EMF types. So transformer EMF is you have a stationary loop and a time-varying magnetic field. Motional EMF is the opposite. The magnetic field doesn't vary, but something about the loop varies.